Hello, today we're going to talk about writing linear equations 3. All right, the first thing we're going to talk about is parallel lines. So when you see parallel lines, what that means is you have two lines that have the same slope and they'll never cross or never touch. So both these lines go on forever and ever in both directions and never ever touch. So examples of this would be if I have y equals 2x minus 5 and y equals 2x plus 4. All right, so if I graph those, all they have is different y-intercepts, but they're both positive slopes and they both go at a constant rate of 2. So they'll never touch and their slopes will always be the same. The y-intercept can be completely different. Let me do a couple examples. All right, again, parallel lines will have the same exact slope. To find out if they have the same slope though, sometimes you'll get it in this form, so I need to switch it. So I need to you always have to put it in this form, which is the slope-intercept form. Subtract x from both sides. Gives me 2y, negative x plus 5, divide by 2, divide everything on that side by 2. Y equals negative 1/2 x plus 5 over 2. So I don't care about the y-intercept whatsoever. What I want to know is, do the slopes match up? So the slope of this one is negative 1/2. The slope of this one is negative 1/2. They are parallel. Over here, we're going to figure out which ones are parallel with each other. All right, so the slope here is 3. So I'm looking to see if any of them match the slope of 3. So here I have to put this in slope-intercept form. So what's the slope? Well, the slope is 3. It's always the number in front of the x. Now it doesn't matter if their y-intercepts have to be different too. If their y-intercepts are the same, that means they're just all real numbers. They're just on top of each other. That's the same exact thing. Here, so y equals 3x. Now this one doesn't even have a y-intercept. Does it matter? No, we don't care if we're trying to figure out if they're parallel or not. Slope is 3. So this one, and this one are all parallel with each other. Let's see if the last one is. So I have to move the x over and then divide by 2. So I get y equals negative 3x plus 6. So my slope here is negative 3. Is that the same as 3? No. They're not parallel. So those three are parallel with each other. All you're checking on with their parallels to see if their slopes are the same. All right, when you talk about parallel, the next thing that always comes up is perpendicular. So perpendicular is when you have two lines that cross and make a right angle, or a box right there. So they have that square circle. So what you need to remember with perpendicular is opposite and reciprocal. Reciprocal just means to flip, basically. All right, let me show you one first. So if I have y equals negative 2x plus 2, I want to know a line that is perpendicular to this line. All right. So tell me a slope that is perpendicular to this. So I take number negative 2, and I take the opposite. What's the opposite of negative 2? 2. Now I take the reciprocal, or I flip it, and it becomes 1/2. So an example of a perpendicular equation to this would be y equals 1/2 x minus 2, or minus 4. All right? These two are perpendicular. I go opposite and then reciprocal. All right, it also can go the other way. So if I have y equals negative 1/3 x plus 3, what is a slope that is perpendicular to that? Well, I take 1/3, I make it opposite, so it's negative 1/3. Now I take the reciprocal, which just means to flip the 1/3 over, and you get 3/1, which is just 3, negative 3. So an example of an equation would be y equals negative 3x minus 2. Those are perpendicular to each other. All you're looking at here is the slope. Opposite, reciprocal. All right, 2 more examples of this. I want to find a slope perpendicular to that. All right. So first thing I have to do is I have to get it in slope-intercept form. You always have to have it in this form before you do anything. So subtract the x, divide by 4. Y equals negative 1/4 x plus 6/4, which I don't really care about in this case. Oops, sorry. Negative 1/4 x. All right, so now I'm just trying to find a slope perpendicular to negative 1/4. So I take negative 1/4, and then the first thing I do is opposite. What's the opposite of negative 1/4? 1/4. Now I take the reciprocal and I take 1/4 and I flip it over to make it 4/1, which is just 4. So a slope perpendicular to this right here, this was going to be slope-intercept form, this linear equation, is 4. Let's do this one. So now I have to solve it. I always do this the same way. There's actually an easier way. All right, if you just subtract the, well, not in this case, you'd have to subtract the y and divide by a negative. But there you go. When you're switching these, always get rid of the x first and then divide by what's in front of the y. That's what I always do. So see, I subtracted, I'd have to divide there, subtracted the x, divide by the coefficient. So now I need a slope perpendicular to negative 2. So first thing I need to do is take the opposite. What's the opposite of negative 2? 2. Then I take the reciprocal. What's the reciprocal of it? 1/2. So 1/2 is a slope perpendicular to negative 2. All right, now we're going to write equations from this. This is a little bit weird, but this is how I'm going to do it for the thing we're doing. So I need to know first what equation with a line passing to 4 is parallel to line y equals x. All right. So this is how the lesson thing we do does it. So first I need to have my slope. So I have to write a whole equation. So we're going to do what we did before with parallel. So parallel, slope is the same. So if my slope here is what? So if I have y equals x, what is my slope? It's the number in front of the x. So my slope here is 1. All right, now we're going to use the slope formula to figure out the point that goes with it. Now we have 2 and 4. Now this is where this is going to get a bit difficult. So that's my x and that's my y. So I'm just going to do y minus my 4 and x minus my 2. And I'm going to equal that to my slope that I now have, which is 1. I'm going to put it over here. And now you have to solve. Now this is the tricky part. I have to move that whole binomial down there. So to move this, I move it like I do any denominator when I want to get rid of it. I multiply this whole side by x minus 2, and I multiply this side by x minus 2. and I get y minus 4 equals 1 times x minus 2. Distribute the 1, y minus 4 equals x minus 2. Add 4, y equals x plus 2. And that's how you do it when it gives you a specific point. If you're just looking for a parallel line to that, you can just use 1 as your slope and pick any number. This is what it wants you to do when you have that happy point that it has to go through. So now we're going to do the same exact thing. We're going to find an equation of a line passing through the point 2, 2 this time though. Line passing 2, 2. We're going to find equation when it's perpendicular to y equals x. Alright, so this one over here was parallel. So with parallel, the slope was the same. When it's perpendicular though, we have opposite reciprocal. So this is the same equation from before. So my slope is 1. And I take the opposite. What's the opposite of positive 1? Negative 1. Then you take the reciprocal, which gives you negative 1 over 1, which is still just negative 1. So a line perpendicular to 1, the slope of 1 is negative 1. Now we're going to do the same exact thing we did here with the point. So we know our slope is negative 1, and then x and y minus 2 over x minus 2. Multiply both sides by the bottom, x minus 2, x minus 2. So I get negative 1 times x minus 2 equals y minus 2. I know this is a lot. I want to do it this way, but this is how it's showing you. So that's how we're going to do it. Negative x plus 2 equals y minus 2, add 2, add 2. So your equation here is y equals negative x plus 4. So really the trick here is you know how to find the slope of both. Equaling it, so it's a 3-step process. You find the slope that's parallel or perpendicular, whatever it's asking for. Then, after you find the new slope that's perpendicular or parallel, equal it to the slope formula, and then plug your points in and solve. That's what you have to do. This is the tricky part here. So, I hope we're going to do one more example. All right, this is the last example. And we're going to do it parallel and perpendicular. I'm going to go through it a little bit faster. So I have to solve it. So I'm just going to add y to both sides to make it quick. So y equals 2x minus 7. Do the same thing over here. So it's going to be 2x minus 7, y equals. My slope is 2. Slope is 2. Now this is where we differentiate. So now I know my slope is 2 over here. It's parallel. My slope is the same. Let's say they're both through the point 4, negative 1. Alright, so that's my x, that's my y. So now 2 equals y plus 1, because that just means to change the sign. And x minus 4. Multiply this by x minus 4, multiply this by x minus 4. So I get 2x minus 4 equals y plus 1. Distribute 2x minus 8 equals y plus 1 minus 1 minus 1. Y equals 2x minus 9. That's my parallel. Now let's do the perpendicular one. So 2, I take the opposite, so make it negative 2. Then I take the reciprocal, negative 1/2. All right, now we have our new slope and we have our point. Let's figure out what it's going to be. So equals y plus 1 over x minus 4, multiply this by x minus 4, multiply this by x minus 4, negative 1/2 x minus 4 equals y plus 1. Distribute, so negative 1/2 x plus 2 equals y plus 1 minus 1 minus 1. So it's negative 1/2 y equals negative 1/2 x plus 1. That's perpendicular, this is parallel. All right, this has been writing equation 3. It's been a pretty long video. There's a lot that goes with it. I hope it helped. Good luck.